Right, we're off and running. Okay, morning, year 13. Thank you for logging on. Every Tuesday morning at 10 o'clock, you're going to have an A-level maths lesson, okay? So it has been published now, the official live lessons timetable put on the website, so make sure you are keeping track. Right, let's remind ourselves of this R alpha method to solve a cos plus a sine or a sine plus a cos equation, right? So if you remember, I told you that in the formula booklet, there are two identities, one for sine A plus B and one for cos A plus B. And we've also used them in the double angle derivations as well. The sine A plus B is sine A cos B plus sine B cos A. And the cos one is cos A cos B minus sine A sine B. Now you don't need to memorize them because they are in the booklet, okay? And what we're going to do, we're going to use those identities to turn this expression here into something a bit more manageable. And usually then they ask you to find values of theta. Now this particular year, instead of using theta, they used the Greek letter phi, okay? And on the next question, they'll use the letter x. And you mustn't get freaked out about that. It really obviously doesn't matter what symbol is being used. And if we write out the full derivation, we can equate the coefficients of cos phi and sine phi to root 5 and root 11. So I hope this is starting to jog your memories. Now, because this is a cos one, can I recommend on your bit of paper, whatever you have in front of you then, you write out cos phi plus sine phi, and then write out the full identity. So it would be cos phi cos alpha minus sine phi sine alpha. And don't forget, you'll have an R in front of both of those, right? So I'm hoping on your bit of paper now in front of you is R cos phi cos alpha plus R sine phi sine alpha. And that's just an identity out of the booklet where they've swapped the letters A and B, in this case, for phi and alpha. Now, if you look at it, in front of cos phi, we have root 5. And down here, where you should have written what I've just asked you, our coefficient of cos phi is R cos alpha. So you were able to write down there, R cos alpha equals root 5. If we look at our coefficient of sine phi, it's root 11. And when you've expanded this here, you will have R sine alpha is the coefficient of sine phi. So you can write down R sine alpha equals root 11. Are we all still there? Okay. Right, now, we can, yay, thank you, Catherine. Now, we can do two things with that. The easiest thing to do now is to square them and add them. So see if you remember this. If I square them and add them, I'm going to end up with R squared cos squared plus R squared sine squared. And if I factorize that, I get cos squared plus sine squared, which is equal to 1. So it just disappears. So effectively, I get R squared is this squared plus this squared. And that allows me to get the value of R, which is the square root of this plus this, which is 4. Right? Obviously, I'm going to show you all this in a minute. I'm just trying to get you to write it out yourselves first. And if I divide those two equations, if I divide my R sine alpha equals root 11 by R cos alpha equals root 5, obviously the R's cancel. I get sine over cos, which is tan. So then I can write down tan alpha equals root 11 over root 5. Hit the shift button on the calculator and I will get a value for alpha, right? So I'll do tan to the minus 1 of root 11 over root 5. And I've got here alpha is 56 degrees. Okay, so let's just check we're all right getting up to that point. So this is what I've written out here. I expanded this, and stupidly I didn't actually write it down. I figured out that r sine alpha is the coefficient of sine phi, which is root 11. R cos alpha is the coefficient of cos phi, which is root 5. You square, add, and root these coefficients here to get the value of r. So if I square that, it's 5. Square that, it's 11. Add them up, 16. Square root is 4. Take a breath. And then divide these two. And alpha is tan alpha is that over that, sine over cos. Hit the shift button, and I get alpha is 56 degrees. So effectively, I can rewrite this. I can rewrite root 5 cos phi plus root 11 sine phi in this form, which is what they've asked me to do. R is 4 cos brackets phi minus 56. Okay. Now we had sort of done a few of these a couple of weeks ago. I want to now talk to you about the next part of the question, which isn't difficult. It says use your result to part 1 to find the least value of this here, right? And write down a value for phi for which this least value occurs. Now this, of course, is a fraction. It's 1 over something. And for it to be the least possible, we need the denominator to be the biggest possible. Okay, so take a second to absorb that. For a fraction to be its least value, we need the denominator to be its biggest value. So I'm going to rewrite this out here, but I'm not going to write the denominator like this. I'm going to swap it for this. I'm going to swap it for what I worked out. Oh, well, that's. Thank you, Natasha. I'm sorry. Can you see it now? So was that the most pointless 5 minutes of your life ever? Oh, no one's going to say yes. You're so nice. Right. I'm not going to start again. I bet it was getting a bit confusing. Right. I just went through how we turn root 5 cos phi plus root 11 sine phi into this expression here. I'm not going to go through it again, right? Because we'll do another one in a moment. We're now going to look at how we use that result to find the least value of this fraction here. For a fraction to be at its least value, the denominator needs to be at its most. So I need this root 5 cos alpha plus root 11 sine alpha plus 6 to be the most it can possibly be. Now what I'm going to do is I'm going to swap this bit here for the expression I worked out earlier. I'm going to swap this bit for my 4 cos brackets phi minus 56. I'm going to scroll down, and I get this. Okay, so I worked this bit out in the first part of the question. So they are actually the same thing. So to find the least value of this would be the same as finding the least value of this side. Now, the least value occurs when the denominator is at its maximum. The maximum value you can have for cos of something is 1. So the maximum I can have for this part will be 1. 4 times 1 is 4. 4 plus 6 is 10. So the least value of this here will be 1 over 10. They then ask for at what value of phi will that occur? Well, if you know your cos and sine graphs, you'll know that cos starts at 1. So cos of 0 is 1. So I need this bit here to be 0. So obviously, for that to be 0, phi would have to be 56. 56, take away 56, would give me 0. Cos of 0 is 1. 1 times 4 is 4. 4 plus the 6 is 10. So that's where it all came from. Mega sorry I didn't have the screen up. Shall we just look at the next one? Start again at the next one. Loving the conversation. Right, okay. Here we go. Ooh, that's the answers. Don't have a look at the answers. Okay, let's look at a similar one here. Express this here, 8 sine theta minus 15 cos theta in the form r sine theta minus alpha. Okay. Once you've done that, find all the values between 0 and 360 that will satisfy this equation. So obviously we will have replaced this for our r sine theta minus alpha values, and we'll solve it. Once we've done that, determine the greatest value and the least value of this expression. So to get the greatest value, we'll need the smallest possible denominator, and to get the least value, we'll need the biggest possible denominator. Right, so the first thing we want to do is write out this expansion here. So it's in the booklet, right? But it'll be r sine theta cos alpha minus r sine alpha cos theta. And then you can equate the coefficients of sine theta and cos theta to this 8 and 15. So everybody have 60 seconds trying that. So write this out here, r sine theta cos alpha minus r sine alpha cos theta, and try and equate the coefficients of sine theta and cos theta to 8 and 15 and see what you get. So I'm hoping you have r cos alpha equals 8 and r sine alpha equals 15. Anybody got that? Anybody willing to fib and just say yes so I know I can move on? Brilliant. Thank you, Catherine. Now, if you square, add, and root those values, because the sine squared plus cos squared will disappear, then I can work out the value of r, right? So if you do 8 squared plus 15 squared, and then just take the square root of that, you'll get the value of r. So chuck that in your calculator now. It comes out as a whole number. And if you divide those two expressions, you'll get the value for tan alpha. So don't forget, it's got to be sine over cos. So you should have tan alpha is 15 over 8. Press shift tan and get me a value for alpha, please. So this is what I got. My coefficient of sine theta was r cos alpha, which was 8. My coefficient of cos theta was r sine alpha, which was 15. Square, add, and root them, and I got r was 17. Divide them to get tan alpha. Tan alpha is 15 over 8. Don't forget you got to do sine over cos. I hit the shift button, and I got a value of alpha for 61.93. Anybody get that as well? Did I go too fast? No one said yes. Thank you, Hannah. Where do you think you messed up then? Did you get r was equal to 17? A common way to mess it up is to get these values the wrong way around. You might have done tan to the minus 1 of 8 over 15. Okay, so you must remember it's the sine over cos, so in this case 15 over 8. Okay, right, so let's move on. So now they want us to solve this equation here of all values from theta to 360. So I'm going to swap my 8 sine theta minus 15 cos theta. I'm going to swap that for what I just worked out. And what I just worked out was r is 17. So it'll be 17 sine brackets theta minus, and my value of alpha is 61.93. Right, so write that down. 17 sine brackets, radians. We're in degrees. Easy mistake to make up. 17 sine brackets theta minus 61.93 minus 7 equals 0. And I'm hopeful you'd be able to take it from here now, right? So take the minus 7 over, it becomes a plus 7. Take the 17 over, it becomes a divide. So you've got 7 over 17. Do sine to the minus 1 of 7 over 17. Use your cast diagrams or graphs to get all values of theta in 0 to 360. And then finally, take over your 61.93 as an add. I'll give you 60 seconds. Let's see what we get there. Well done for having the right answer now. Is that enough time? Shall I show the solutions? Anybody want another minute? You've got to tell me. I don't want to just keep spoiling the fun, but I have no idea because I can't see what you're doing. So if nobody types in, give me another minute. I'm going to go through it. Okay, so this, thank you, Hannah. So this is what I've got. I took the 7 over, it became a plus, divided through by the 17, and then did sine to the minus 1. A calculator said 24.32. I know from my graphs I need to then subtract that from 180 to get 155.68. And then I bring over my minus 61.93 as a plus to get these two values here. Okay? Anybody get the same? Well done. Now the last bit of the question, well done Catherine, well done Hannah. Last bit of the question, determine the greatest value and the least value of the expression. Now, that looks meaning, but it's not. It's only worth 2 marks, right? So we're going to replace this again. We're going to replace this bit now for our 17 sine brackets theta minus 61.93. All right, so let's write that out again. Now, of course, the least value will occur when the denominator is at its maximum. The denominator will be at its maximum when this here is 1. Right? The largest value you can have for sine of anything is 1. If this is 1, I got 1 times 17 plus 7 is 17, plus 23 is 1 over 40. So the least value will be 1 over 40. The maximum value is when the denominator is at its smallest. And the smallest value sine or cos can have is minus 1. Right? So if this came out as minus 1, I would have minus 17 plus 23, which is 6. So the maximum value it can have is 1 over 6. Does that half make sense to anybody out there? Right. Now I'm going to let you have a look at the next one completely on your own. All right? I'm going to give you 5 minutes to completely have a go on your own. All right, it's not good. Show me the answers. Richie boy, get it together. Okay, so this time we've got 5 sine x minus 12 cos x in the form r sine x minus alpha. Find the minimum, so do the usual stuff to get r and to get alpha, right? So equate the coefficients, expand that, equate the coefficients, square add root to get r, do the sine divided by cos coefficients to get alpha, tan alpha. Replace this then with your new expression so you can work out the minimum value. Don't forget you need the denominator to be at its maximum, for this fraction to be at its minimum value. And then again, replace this bit for what you've worked out earlier. Take the 3 over as a minus, etc., etc., and get all the values between 0 and 360. Right, have a crack at that. I'll give you a full 4 minutes, and then I'll go through the solutions. Right, so I will start you off. So expanding this is r sine x cos alpha minus r sine alpha cos x. Say it again. R sine x cos alpha minus r sine alpha cos x. Right, have a crack. We've got about 2 minutes. The value of r comes out as a whole number, unlucky for some, there's a clue. And the value of alpha is in between 65 and 70. Pretty much in the middle of 65 and 70, not far off. So if you haven't got that, don't continue with the rest of the question. Tell me and I'll go through it. Right, you know what I'm like, can't help myself. So there's the first part. So the coefficient of r sine x was r cos alpha, and that matches up with the 5. The coefficient of r cos x was r sine alpha, which matches up with the 12. Square, add, and square root to get the value of r, and it's 13. You should have known that. There was a Pythagorean triplet. Divide them, sine divided by cos to get tan alpha. That's 12 divided by 5, and it comes out to 67.38. Anybody agree with that? Please? Well done. Thank you. Thank you. You two. The only two. Thank you. Thank you. Right. Well done, Griff. So what you're going to do now is you're going to replace this here with 13 sine brackets x minus 67.38. And of course, to get the minimum value, I need the denominator to be at its maximum. So sine brackets x minus 67.38 will have to be 1. So I'll have 13 times 1 is 13, plus the 15 is 28. So you should have the minimum value occurs when the denominator is maximum, 4 over 28, which is 1 over 7. That's the minimum value of that expression there. And then the last bit is with 4 marks, which makes me think, There might be a little tiny twist in it because it's normally only worth 3. Solve that equation then. So I'm going to replace all of that with my 13 sine brackets, x minus 67.38. Take the plus 3 over as a minus, divide through by the 13, and press shift sign. Now, if you've done it right, I think your calculator will say minus 13.342. And I would imagine your first instinct is A, it could be wrong, it's certainly not wrong, and it's not in the range of 0 to 360, so I'll bin it. But you mustn't bin it, okay? Because don't forget, in a moment, you're going to bring over the minus 67.38, and it'll become a plus, which will put that negative 13 value into range. I think that's why there was an extra mark attached here. So there was my expression. Took the 3 over, became a minus, divided through by 13, hit sine to the minus 1, and I got minus 13.342. I think my calculator would have said that. I know my sine graphs, so I would have known I would have to add that on to 180 to get my other relevant value. Then bring over the minus 67.38 as a plus, add it to both of those, and there would have been my two answers there, 54.04 and 260.72. Anybody manage to get that on their own? Got 5 minutes on that? Oh, what did you get? If you didn't get that, what did you get? Don't get how you find the angle. Right. So you don't get how you solve this equation?
No, the equation bit's fine. It's just the angle at the end. The x minus 67 bit.
Okay. So you're happy with this part here, and you're happy taking the 3 over and it becomes a minus and dividing through by the 13. Happy with that?
Yeah. And
then you press inverse sine on your calculator, sine to the minus 1 of this, and your calculator should say minus 13.342. You get that?
No, that's the bit I get, but it's fine now. Thank you.
Well, I might have got it wrong. Let's have a look. Did anybody else get that? So second function, sine brackets minus 3 divided by 13. Yeah, my calculator says minus 13.342. And then my nerd skills kick in, and I know that because of the shape of the sine graph, that's gone left of the 0. I need to add it on to 180 to get my other value. And then to finish it off, I bring this over, and it turns into a plus. Does that help at all?
Yeah, thank you.
Oh, you're very welcome. Griff, did you get that? Sam, anybody? Natasha?
No, I didn't get any of that.
Right, where did you get lost, Griff?
I don't think I went beyond the first part, A.
Right, am I going a bit too fast? I'm sorry, mate. It's so hard to gauge the pace when I can't see your faces and see what you're writing. But all the solutions are there, Reese. You're just going to have to watch it again, I'm afraid, mate, okay? Yeah, I understand you was a bit lost without your cast diagram. That's why I use graphs, and that's why it was worth the extra mark. I wanted to go through this one. It was particularly stinky, look, because this one came out as a negative. Now, I'm hopeful that the R alphabet, getting the first set of marks now, you're starting to get the hang of and getting used to it. It's the same thing every time, really. You just expand the identity and equate the coefficients, square add root, and then divide them and hit shift 10. The new stuff today was this bit, the minimum and maximum value of these. And of course, all you got to remember is to get the minimum value of the fraction, the bottom has to be at its maximum, which for sine and cos is 1. And for the maximum value, the bottom has to be at its minimum, and for sine and cos, that's minus 1. Okay, and they've never really gone anywhere else with that. of all the past paper questions going back to 2005, this is the only way they've assessed it. So I just wanted to go through that today, okay? Right, now for that, that's it. There is one more question in the packet. Right, I skipped it somewhere, I don't know where it is. This one here, right? But we've done one very similar. We've used the coefficients of 8 and 15. So I'll let you do that one on its own. And it says, find the greatest possible value for k for this. And of course, there's no fraction this time, so that confused the students. That, hang on, there's no maximum or minimum. What am I going to do here? Well, you're just going to figure out what r sine x plus alpha is. And the greatest possible value will be when sine is 1. So it'll be 1 times r, whatever r is, 17. So that's going to be your greatest possible value for k. And it did ask, give a reason for your answer. And of course, it's because the maximum value of sine is 1. Right, now I don't want to end there. So everybody take a breather, have a stretch. I want to quickly show you something else with the double angle. So while we're still on this a plus b stuff, I want to show you something that I've got a sneaky feeling they're going to throw at us this year on the double angle, right? And it's this. It says find sine of 3x in terms of sine x. All right, so I'm just going to talk you through this proof. I'm sure you'll be fine with it. I'm going to talk you through this proof. And I'm going to ask you to do it for cos 3x as like your homework, right? So, consider the expression sine 3x. We're going to use the addition formulae and double angle formulae to write this in a different form, using only terms involving sine of 1x and its powers. And the first thing we're going to do is think of 3x as being 2x plus 1x. Okay, and then we're going to use the sine a plus b identity that we've already used today with the r alpha. So I'll just say that again. Think of 3x as being 2x plus 1x. So that's the first part we write out. Sine of 3x is sine 2x plus 1x. Now, knowing that identity of sine a plus b is sine a cos b plus sine b cos a, that's this line here, right? So that's sine 2x cos 1x, sine a cos b, plus cos 2x sine 1x, cos a sine b. Hopefully you're still with me. Now we've also, in the previous lesson, shown how we can rewrite sine 2x and cos 2x using the double angle identities, right? And we proved all that last time. So instead of sine 2x, I'm going to rewrite that as 2 sine x cos x. If you remember the identities from last time. And instead of my cos 2x, I'm going to rewrite it as this one. Now, if you remember, there was 3 options for cos of 2a, or 2 theta, or 2x, or whatever letter you want to use. And we're going to use this one here, right? Because we want to get it all in terms of sine. So I'm going to swap this cos 2x for 1 minus 2 sine squared x. Now let's tidy all of this up. I'm going to tidy it all up now. So multiply this by cos x. I get 2 sine cos squared x. And over here, my 1 times sine x is obviously sine x. And my minus 2 sine squared x times sine x is minus 2 sine cubed x. Take a deep breath. Now, this cos squared x here, I can replace that using the identity you know from last year. Cos squared plus sine squared equals 1. So I'm going to replace that for 1 minus sine squared x. And then tidy it all up again. If I multiply this bracket out, I've got 2 sine x minus 2 sine cubed x, and then plus what's left over here. And then the final bit of tidying up, I can put my minus 2 sine cubed minus 2 sine cubed as a minus 4 sine cubed x, and my 2 sine x plus sine x as 3 sine x. So what we've done there, we've taken the sine of 3x's and rewritten it in terms of sine of 1x. 3 sine x minus 4 sine cubed x. And all of that came from using sine A plus B, the double angle formulae substitutions, and cos squared plus sine squared equals 1. Now, I'm not going to fib. It's due to come up. Okay, it's due to come up. One year, a few years ago, we had it in terms of tan. So the sine or the cos one is due to come up. And you just got to sort of learn it off by heart, really, right? But what I'm going to ask you to do now, for a laugh, for a bit of fun, I want you to do exactly the same process and get me cos of 3x in terms of cos x. I haven't written the answer down. It's not going to look too dissimilar to this, okay? It won't look very dissimilar at all. It might be in a slightly different order. But of course, you're going to use the cos A plus B, and you're going to use a different double angle formulae substitution. So I invite you to have a go at that for homework. I will post the solution up in a day or two when people have had a chance to watch the vid of the lesson back, etc., etc. Okay, any questions for me? I was talking to Bouncy earlier. Our coverage at the moment of the A2 unit is very, very good. In terms of the pure side of it, we're pretty much done now. We're pretty much done. There's a couple of things. He's done all the stats, he told me. And there's a couple of things in mechanics left to do, vectors and differential equations. So that'll be our next push for those 2 topics. And then we're just going to start looking at exam questions. We still don't know yet exactly how you're going to be examined. But you will be in some way. Okay, so the more practice we have at the exam questions, the better. Please read through that proof again and then try and do it all for cos 3x. So split up the 3x into 2x plus 1x and go from there. If there are no questions or no comments, I bid thee farewell. And I will look forward to seeing you next week. Right, so I think you've got a lesson with Bouncy on Friday and it's me on a Tuesday. So take it easy. Bye-bye, everyone. You're all very welcome. Bye-bye.